Yeah, hey everybody. So welcome to another PIBBSS Speaker Series event. Today we have Alan Love, professor of philosophy, specifically philosophy of biology at the University of Minnesota, and not the University of New Mexico. Um, Not that I actually thought that, but yeah, so he's here today to talk to us about complexities in the concept of biological agency. So I'm going to turn it over to him, and I think that he intends to have sort of a brief presentation and then mostly open it up for a conversation. So just raise your hand if you have a question, and I will allow you to talk and unmute you. Thanks, Alan.
Yeah, thanks, Zach, for the introduction. And yeah, just to reiterate, my aim will be to sort of do some stage setting here at the beginning so that we sort of have a common uh, uh, basis from which to have our conversation. And hopefully, uh, given that I'm coming from a different place than I know some of the others in the group are, it will also mean that we can kind of productively go back and forth in terms of questions and answers that will be fruitful for ongoing research that we're all doing. So basically, just to kind of give a slogan at the beginning, agency is complicated and controversial. It's a concept that has been around since antiquity, and arguably has never gone away, and yet has retained that sort of furor and complexity throughout that whole time. If you think back into the antiquity and somebody like Aristotle, a concept like agency is at the very base of his view of the biological world. Um, and in particular, he has an insight that continues to capture a lot of people even today, which is that to be an agent is to be organized in a certain kind of way, to be organized in such a way that one can undertake certain activities. Now, for Aristotle, that was a distinct sort of set of commitments that we're not going to get into. But the point is that he had that insight, and a lot of people, even if they disagree with the kind of organization um, uh, uh, that they currently think is important, then they still think that insight that organization is central is there. So if we sort of jump forward in time quickly to the early modern period, what happens in the early modern period is that a lot of people become enamored with thinking about machine-like conceptions of the organism, both because of industrial developments and because of developments in natural philosophy. At the same time, there's a continued acknowledgement and concern that what's happening in living systems is different, that somehow living systems have a vitality, an agency that the non-living systems don't. And this, what that is, controversial, how to think about it, complicated, but that sort of dialectic becomes a little bit more poignant because for the first time, there's more of a challenge to whether or not there is something that is there. Prior to that, people would have presumed that there was agency, and then the question was just what it was. Now you get for the first time the possibility that what may have looked agential might not be agential. And so the first, what we would think of as like automata or robot-like machine creations emerge that have people sort of thinking about this as a possibility. At the same time, the biologists studying the natural world are fully aware that the behavior and activity of living systems still seems far and away distinctive compared with those automata. As we move into the 19th century, there's increasing attention to the chemistry of life and thinking about life as a phenomena that needs to be analyzed from what we would think of as lower levels of organization, and that obviously continues into the 20th century. But there's a kind of moment in the early 20th century, right after that 19th century kind of push on thinking about the chemistry of life, and especially to just lower levels of life forms. The cell in particular, cell theory developed in the 19th century, that we get arguably some of the strongest statements of what might be called a kind of materialism reductionism view within the biological sciences, that says, look, that perception that there's something distinct or different going on in organisms is maybe just an artifact of our not understanding them systems well enough. Once we understand them, and especially if we understand their components and their sort of molecular architecture, then what previously we thought was this distinctive feature agency just starts to fade away. Now, intriguingly, you might think, oh, well, that's where we currently are today. But in fact, no, because within a short period of time after that, there was a recognition among a number of theorists that this was not adequate, that in some sense, the achievement had been done under the conditions of theft rather than honest toil, that we actually hadn't said, well, here's what the organization is that yields agency. They'd rather just said, well, we're going to get there and stop worrying about it. And so these folks sort of realized that we actually needed some kind of theory of systems that would somehow provide a way of thinking about that organization that was not being offered just by studying the molecular chemical constituents of living systems. And this is the rise of cybernetics and systems theory that some of you may be aware of. And it also coincides with developments that include the rise of computing and computer power, and the first glimmerings of artificial intelligence. The idea of a Turing test is emerging in this time. And so what we have is, in a sense, a recognition that, again, agency is complicated, but now with this kind of looming shadow that, well, is it the case that it's really there, or could we somehow eliminate it or undermine it with the study? The prospects were not as rosy as some of those early 20th century biologists like Jacques Loeb argued, but there was still going to be this specter of, you know, do we have something genuine and distinct, and how to cash that out theoretically and make sense of it in light of the developments within technology as well. So probably the example that I like to use the most to sort of bring us right up onto the present, because this was a potted history, so we're just kind of doing the history to orient ourselves, is to just zoom in on a contemporary behavioral biology laboratory today. And if we were able to tour and talk with a behavioral biologist who's studying basically how do butterflies choose where to lay their eggs, they would talk freely about preference and choice. They would design experiments to see if they could determine whether or not particular preferences are had by those butterflies in terms of where they lay their eggs, and whether or not particular choices are made when there are alternatives put forward for those butterflies. But there would not necessarily be any further reflection on the agential assumptions that are at the back of saying the butterfly has a choice, the butterfly has a preference. And so I think that this is sort of where we are today, which is that we can very easily see on the landscape of modern biological research that agential inflected notions remain with us strongly. However, if one was to ask that behavioral biologist, what do you mean when you say the butterfly has a preference for that plant in order to lay its eggs? They might respond to you with, I don't know, I've just operationalized that they can have a choice between these two leaves. They might say, well, the organism has a preference, the organism has a choice, and they might sort of have a more robust sense of agency. And then others might say, oh, it's all just a kind of as if language. You know, we talk as if the butterfly has a preference or a choice, but it doesn't really have a preference or a choice. It's all, say, a deterministic system that can be cashed out in terms of, say, molecular constituents or something like that. So the point is that we find ourselves in the present, at least in the biological sciences, where everybody talks about agential notions. They talk about organisms having directed behavior, but what that means is oftentimes not specified. And if you scratch just below the surface, you will find tremendous disagreements, if not simply a lack of specification. So that's just a little bit of a history, and it's meant to kind of remind us that the question about agency broadly is one that is complicated and controversial, but also, secondly, involves attention to the mechanical, the machine, and the artificial. Because through that early modern period up into the present, one of the things that drives the conversation is developments in technology, is people paying attention to what kinds of behavior can systems that humans have built give us insight into those systems that nature has built, to sort of use a metaphor. Now, for my purposes as a researcher in philosophy of biology, one of the things that I have been keenly interested in doing in the last few years with this large project I've been involved in, some of you may or may not know about this, so I'll just say a little bit about it, which is this project is called Agency, Directionality, and Function. And it's an attempt to bring together different disciplines, primarily biological and philosophical, to talk about different phenomena in the life sciences on different timescales and different spatial scales, to try and get at this complexity, but by doing something that maybe is counterintuitive, which is, instead of starting with a let's get clear on what agency is, finding somehow a single consensus definition, and then going to, say, look in nature and ask, do we find things that correspond to that definition? Instead, I wanted to sort of flip the script and say, don't worry about exactly what agency is. Instead, figure out ways to study those properties, those features that are typically associated with agency. Why? Why do it that way rather than find the consensus definition? Well, for one, there's not going to be a consensus definition because it's complicated and controversial, and it's been argued about for a long time. But secondly, it comes from the observation that, in fact, other areas of the sciences proceed just fine without having that single consensus definition. For example, biologists do not agree on what counts as a species. They have a number of different ways of talking about species. Those come along with particular operational definitions that allow them to go measure or take data and then use it, but there isn't a single consensus definition. And yet people don't go, well, we just gave up talking about species because we couldn't agree on what a species is. No, instead, what they did was they found productive ways to peel off some part of what is thought to be important for species, such as reproductive isolation or ecological coherence or phylogenetic lineage, and then studied that and figured out ways to get more clear, more precise, more specific about those features without having to come to a single consensus definition. So in the same sort of way, as a part of this big project, I want to advocate that kind of shift for agency. Don't ask, what is agency? But instead ask, how do we study different properties that are associated with agency in some sense? And the properties that we focus on can be those that we are most interested in, given certain research projects or disciplinary orientations that we start with. So what that means is that we change a sort of definitional question into a question about modeling choices. Because once you start to think about how do we study those properties typically associated with agency, you have to start asking, where do you look? And what do you look for? The where do you look, which is something I won't spend as much time on in our sort of opening conversation, but I'm happy to come back to that in discussion, is simply you got to have a model organism or a system that you look at. And sometimes that is because it's the most convenient or the one that allows for the most experimental manipulation for the kind of tools that you are interested in doing. It even could just be, this is the organism that I'm the most comfortable with because that's what I was trained to work on in my graduate school experience. So there's where to look, but really the thing I want to sort of highlight for us is this, well, what are we looking for? What are those properties that are associated with agency that some people maybe thought were constitutive of agency, but disagreed about that we can then investigate? And I think there are basically 4 broad categories that we can pay attention to in this space. And we can sort of break those up into 2 that are inside and 2 that are outside. And by inside and outside, I just mean a kind of intuitive distinction between, are we looking for those properties inside the organism, or are we looking for those properties outside the organism in some respects? So let's start with the first 2 on the inside of the organism. And the first one is going to take us back to the point we already made about Aristotle's intuition, which is that we somehow look to the organizational structuring of the living being, that the being is organized in such a way that it can take advantage of differences and make choices or have preferences of some kind. And almost universally, people think that that's got to be some kind of feedback architecture. So this is inheritance from cybernetics. People think whatever kind of organizational architecture an agent might have, it's some kind of feedback structure. However, it's not just standard negative feedback structure, because we can find that in a thermostat. A thermostat has negative feedback architecture, and we don't think that the thermostat is an agent. So what is it that we might be looking for? Well, 2 different things are usually highlighted. One is that the feedback control is nested in some respects. That is, there's systems that control systems rather than a single layer of systems. And the reason why that's thought to be important is that somehow is how an organism can take advantage of the feedback without being somehow determined by the feedback to go one way or the other. If it was a mono layer of feedback control, then like the thermostat, you would either turn off or turn on. But if you have these higher levels of control over those systems, then somehow the system can increase the degrees of freedom that it has, and thereby be more agential. The second thing that is a part of that feedback architecture is that it is linked to mechanisms of control. So it doesn't do any good if you have the ability to monitor a situation and recognize different kinds of choices that could be made, but you can't do anything about it. And so in addition to this feedback architecture, being able to sort of monitor situations and deal with feedback and perceptual input, there also has to be some kind of output. There has to be some way in which that translates into a action. So associated with this is one of the trickiest parts of the inside for agency is basically, do you have to have a goal? Do you have to have a representation of a goal state? I mean, to put it a little bit more concretely, does the squirrel have to be able to envision that the nut it is putting inside of a cache as something that it will discover later in the winter when it's hungry? When you put it that way, some people's reaction is, well, of course not. Squirrels don't think about the future in that way. They don't represent their goals. And that in fact, if you look at the research that's done on squirrel nut caching for the winter, squirrels oftentimes completely forget, so to speak, where they've put the nuts, and those are never found again. So it would seem like there's some kind of disconnect and not as clear of a mental representation of what the squirrel is doing. However, at the same time, people have highlighted that that sort of goal representation may not be necessary. Well, here we are at one of those sort of controversial points about the inside architecture for agency. Is it the case that that feedback organization and capacity for action is somehow linked specifically to a representation? Answer is, we don't know, and that's part of what is currently debated. Okay, so that's one feature on the inside that we might look at, and if we were going to study it, we would then study what's the feedback structure like, what are the capacities for action, what kinds of abilities for representation does the system have, and so on and so on. The second internal feature is what we might broadly call autonomy. And here, the idea is that for an organism to display a kind of agency is for them to not be determined by what's going on outside of them. That to some degree, the autonomy from the environment is a part of being an agent, because that gives the organism the capacity to do something that's not dictated to it by its circumstances. Now, this can come in lots of different flavors, and we can see why it's also immediately controversial, because you could argue that we have a thermostat, our own homeostasis as a warm-blooded mammal that maintains our body temperature independent of the environment that we are in. However, that homeostatic process doesn't seem to constitute agency. At the same time, if we didn't have that sort of capacity, then it would seem to suggest that we would maybe not have at least some of the capacities for action and features that we were just talking about that are also internal, that seem to suggest agency. So some kind of autonomy, some kind of boundary with the environment, where the environment doesn't just dictate what's going on seems to be important internally for thinking about agency. And then if we were going to model that, we would need to then ask, well, what kinds of autonomy are we talking about? We're talking about spatial autonomy, so that we're talking about boundaries between, say, insides and outsides of an organism. Or are we talking about autonomy in the sense of time delay, the ability to pause or not engage in an action right away in response to some stimulus, but rather to have evaluation. And in fact, some people have even argued that a hallmark of agents is time, that instead of making immediate actions, they can time delay the activities associated with what they're doing. Okay, so that gives us two kind of key things that we might look at and want to model on the inside. Sort of feedback, organization, and control and autonomy. Okay, now shift our perspective to outside. In thinking about what it constitutes agency, one of the things that is relevant is, do you have alternatives? So if I am thinking that I have agential capacities, part of those agential capacities should be about my ability to select from among alternatives. If I don't have alternatives, what does it mean to make a selection, to have a choice, to have a preference of some kind? However, my ability to have alternatives is going to be a function of what kind of organism I am, because what kind of organism I am is going to affect what kinds of properties I can or can't detect in the environment. And so a bacterium is going to have potentially some alternatives in terms of, say, a sucrose gradient and which way it might swim, but it's not going to be affected by, say, what kind of music is playing on the radio or something like that, because it doesn't have the relevant sensory apparatus to detect that and then be affected by it. So this is usually talked about in terms of a key term called affordances, which is that an agent is an agent precisely because it can somehow detect features of the environment that it can choose from among or make use of in some respects. So in that way, we might, again, when we're thinking about modeling, ask the question, what's the environment like? What kind of affordances does an organism of this kind have in this kind of environment? That would be a particular thing to study. And obviously, depending on where you were looking, if you were studying bacteria or you were studying squirrels, that would make a difference. And then lastly, for the second feature on the outside, is the idea of social structure or population. Organisms are largely non-solitary, even if they have stretches of time where they might be solitary, they still often have to come together for purposes of mating and the like. So when we study organisms, we don't study organisms sort of in complete isolation. They're not atoms separated from everything else. And so a key part, and you could think about this as a part of the environment, but I think there's good reasons to think about these biotic dimensions separately from abiotic dimensions. What kind of social structure is there for an organism? And what kind of features of that social structure are relevant for choice and preference and the like? And obviously, those are features that play into things like the reproductive community that you're in, or how offspring are cared for, or the like. But perhaps also we need to keep in mind that it affects things like collective activity, So the degree to which multiple organisms can hunt together and thereby somehow act as an agent as a collective. The capacities to do that will vary, but in almost all organismal systems, there is some kind of capacity to work together. And then again, the question that we are encountering is the degree to which we want to call that agency, because when we observe, say, a flock of birds that are moving in unison, we actually have models that tell us that the birds can exhibit that behavior without needing to know what the whole is doing, and in fact can modulate their behavior purely in terms of their nearest neighbors to manifest that, which makes us think that maybe thinking of that as sort of a collective action may not necessarily be the best way of modeling it. But again, just to set back into context, what we've been doing is we've been saying, look, don't ask what an agent is. Instead, ask what kinds of features do we typically associate agents, and how would we study them, and where would we study them? And so we were picking up on these internal features like feedback control mechanisms and cognitive architectures, or things like autonomy and different types of autonomy from the environment, and then features of the environment themselves, whether that's affordances or certain kinds of population and social structure that might be present. Okay. So at this point, you're probably wondering, what does all this have to do with AI? What does all this have to do with the artificial technological systems that I know many of you are concerned about? And I think that we can simply make the same twist of question that I was arguing for in the biological context. And that is, don't ask, is ChatGPT an agent? Okay, that would be to fall into that single consensus definition conundrum that we talked about before, where you're very unlikely to escape apart from simply having a long debate with people who will say yes and no and yes and no for different reasons. But instead, to say, for any artificial system that I'm interested in, like ChatGPT, what kinds of properties does it potentially exhibit that are related to those things that are oftentimes determined as agential or relevant to agents? And that suggests that those things can be studied, and we can make progress on understanding them with respect to those artificial systems without necessarily having to ask whether or not such a system passes some single test of intelligence, whether it's a Turing test or something else. But in fact, we can understand to what degree those systems do or don't share certain kinds of features with living systems. And so there's two sort of things that I think are worth flagging, and then I'll sort of wrap up my opening comments and we can go to discussion together. The first is to just think about large language models for a moment, and think about how large language models sort of depend on a certain kind of consumption of a huge amount of data in order to come to the relevant pattern detection and recapitulation that we know them by. And we can ask, okay, is that kind of organizational system exhibited by living systems? That is, do living systems exhibit the sort of machine learning style algorithms that we are associating with the artificial systems like ChatGPT or other LLMs. And I think it's not a foregone conclusion, but one of the things that's very interesting, to me at least, is that it is quite difficult for us to disentangle the internal architecture of an LLM because those sorts of training and machine learning sort of rhythms that are engaged in are actually not open and available for scrutiny in the way in which we might think we could open up the cognitive architecture of a organism by studying, say, some of its material constituents, such as neurons and their organization. So we might immediately start to then say it's fruitful to compare and contrast these artificial systems with respect to how they do or don't match certain kinds of things that we see or can do when we are studying organisms. Second thing that I think is of interest is, can it tell us something about where they will go wrong? I know that many people, including a number of you, are interested in artificial intelligence safety issues. So to what degree can a artificial system sort of make mistakes? And is that something that we can somehow either avoid or at least minimize in these artificial systems? And to what degree can we think about that in living systems? So go back to the squirrel example, right? We know that for living systems seemingly can make mistakes, right? So when the squirrel can cache a bunch of nuts and not ever go back to it, thereby somehow losing the energy and investment of having done that in the summer and not being able to take advantage of it in the winter. Now, we might not think of that as a mistake if we think, but the squirrel cached enough nuts that it could find what it needed to eat and survive through the winter. So that suggests that in thinking about mistakes in living systems, we have to be careful about what perspective we adopt in thinking about that. Is it a mistake for a system that is not previously aware of something in its environment to then misjudge it? So a classic example would be animals that had never before encountered humans. When they did, there was no fear. There was no sort of inherent, for a number of them at least, there was no need to run away. And as a consequence, many of them died or were captured. And obviously that was learned over time in some cases, but then you might ask, well, but if they had never encountered that in their environment before, you can't really say that it was somehow a mistake, right? So similarly, if we think about artificial systems like ChatGPT, if the kind of environment that it is operating in is somehow novel, is it really the case that we can say that it has made a mistake or done something wrong, as opposed to simply responded in whatever way it had available to it in a new circumstance? So the important thing there is that just as in living systems, what counts as a mistake will oftentimes be related to the perspective that one takes on the system. So too, I think, in trying to understand, say, to what degree could a artificial system like ChatGPT make a mistake. We need to ask from what perspective are we evaluating that sort of question. So I think, though, that, and I'd be interested in hearing your feedback, it's helpful to be able to make the comparison with the living systems and to recognize those sorts of complexities, because sometimes I think there is a tendency to see the situation with the artificial system as somehow distinct and independent of those considerations. But in fact, the same things are raised in studying living systems. So I'm going to stop there. Let me just quickly rehash where we've been, and then we can just open it up for conversations. So I started with this kind of very potted history of the fact that agency has kind of always been with us, always been complicated and controversial, but that through the early modern period and up into the 20th century, there's an increasing recognition that artificial systems can exhibit some of the features that were associated with agency, which raised the question about whether agency was somehow no longer needed or was not, we didn't need to invoke it anymore. While at the same time, there was a recognition that in some ways, we still needed an account of systems and wholes in order to understand that relevant architecture, oftentimes cashed out in terms of feedback, to see how the systems were operating. And that when we find ourselves in the present with lots of choices being made by biologists about how to study their systems, if we assume that they have to first decide what counts as an agent and come to some single consensus definition, they're very unlikely to be able to do that. But since they don't do that in other domains, there's little expectation that they should be doing that in the space of agency, and instead they should be focusing on the modeling choices that are associated with these different dimensions that I talked about, the internal and the external features of feedback control systems, or how autonomy is manifested versus the environment and the social or populational structure that an organism is found in. And that these sorts of issues, I think, translate quite nicely into the space for talking about artificial systems, both because of the history and the fact that there's the entanglement there, but also because this shift away from, is the artificial system an agent, is oftentimes unproductive in the same way that it would be in the biological sciences, but that focusing on these modeling choices in trying to understand these artificial systems might actually be highly productive for getting past some of the standard debates. So with that, I will stop and happy to basically engage in an extended conversation or elaborate on any of the things that I was mentioning along the way if people would like me to do so.
Yeah, thanks, Alan. That was really great. I suspect we'll have quite a few questions. So yeah, if you all want to raise your hand to ask a question, I will allow you to talk. Yeah, so somebody from the room.
Hello. Yeah, this is actual Clem, not one of the fake ones. Thank you a lot for the talk. As two questions, and I'm coming at them both because I feel like they're related, but I'm not sure. One is the question of like the individuation of agents. So I was kind of, I don't know, I feel like maybe it's kind of like on the boundary between inside and outside, but where the boundary of an agent is, seems to be another important feature that is often discussed with agents. And I'm wondering if you see that as like a separate thing, area of concern, or if you think these are like deeply intertwined things? Or do you think that the concept of an individual is maybe similarly confused as, or like not useful as the concept of an agent? And then second, I know in your writing you've mentioned about the importance of like scientific goals in which definitions we end up choosing. And I think maybe just kind of maybe it's like more of a like shift in emphasis or something, but I think something that's very interesting about what's going on with like artificial intelligence and AI alignment in particular is that there's like it's very heavily operationalized around this goal of wanting to prevent or understand how to prevent agency in a particular kind of dangerous agency from arising in artificial systems. So like how do we stop an artificial system from developing goals or some form of agentic capacity, which is directed at something that we don't want it to be directed to. And so I'm wondering if any of your specific insights into agency are maybe like illuminated, or we can try to spotlight onto them in light of that goal.
Okay, yeah, great. Both really interesting questions. I do think that there's a lot we could say here. Let me start with the first point about individuation. So it's absolutely the case that in the sort of long history, the presumptions about individuation were quite strong. So Aristotle has this clear notion of what's going to count as an organism. It's going to be a certain combination of matter and form organized, as he would say, or as later commentators would call it, hylomorphically. But the point is that as we move into, especially the last 200 years, there's been increasing recognition that the boundaries between individuals turn out to be a lot less clear, and that they are less clear with respect to certain activities that we typically associate with individuals. So that, say, the capacity to metabolize is distributed over what we would have traditionally called multiple organisms. And therefore you don't have this clean cut between, the inside and the outside for, individual 1, individual 2, and so on. First off, I would say that individual and organism are concepts that are subject to a very similar kind of analysis that I'm highlighting for agency, in that instead of focusing on a single consensus definition, what we can do is we can actually make progress by zooming in on the modeling choices related to the properties of interest. So if you just think about the difference between an immunological individual and a metabolic individual, where I pay attention to how does the system maintain immunological boundaries of self, non-self, as opposed to how does the individual engage in metabolic activities. It may be the case that I don't have an account that says an individual is an individual full stop, that everybody agrees on, but I can still productively pay attention to those properties. So that's just to say you can subsume the question of individuation into that same space. Now, as you rightly note, it's going to be complicated because questions about agency will be then entangled with the questions about individuation. And I just think that's inherent to some of the complexity that's involved here. And part of the reason why I think we have to pay attention to those collective dimensions, populational and group structures that sometimes I think are highly relevant to systems exhibiting forms of agency. So I guess, in a sense, the individuation question is another part of the modeling choice. It's another way of saying, how have I presumed that this system has certain boundaries in order to study it in a certain way? And it doesn't mean that I have to somehow have the one right way of individuating the system in order to study it productively. But what it does say is that I should be aware of how I individuated the system in order to study it, because then I can be aware of the advantages and the potential blind spots that come along with that particular individuation. On the second question about scientific goals, I think it's nice. I like the way you put it, that there's this kind of current primary or highlighted concern that somehow artificial intelligence systems will be responsible for some kind of dangerous agency, something that will, cause harm, or, maybe at a more basic level, something like just mislead or something like that. I think that it's absolutely fine if there is an overarching goal like that in the investigation, because then what it does do is focus your attention on, okay, what are the properties of the system that are most likely to be dangerous? In what ways will they, what are the things we need to pay attention to most, where those sorts of boundaries might be crossed into the dangerous. But what I would say is actually that they also might attune us to different kinds of scientific aims that we might have in mind for undertaking that. So if I was trying to understand whether an artificial system would somehow yield dangerous agential-like features, one thing you might want to know is, can I predict it? Can I predict when the system will go rogue? Okay, doesn't mean that I have to predict how the system will go rogue. Maybe I just need to predict that it will go rogue. Or maybe I want to know, could I predict it would go rogue one way rather than another way? But to foreground prediction is not the same thing as saying, do I understand why it goes rogue in that way when it does? Because that's a question about explanation, a question about how we understand the mechanisms or the dynamics of how it's operating. And in an interesting sort of way, sometimes we can have very high predictive value with very low explanatory understanding. And sometimes we can have very decent understanding of the internal architecture of a system, but actually not have very much predictive traction at all. And I think that bringing those sorts of clarifications into the space can be quite helpful, because if somebody's only aim is prediction, or their primary aim is explanation, people might actually, even though it appears that they agree that we're worried about dangerous agency, they actually are not worried about it in the same way. And they might have different then approaches to modeling and trying to get at the relevant features of those systems that would then need to be surfaced so people don't get confused or talk past one another. I hope that was helpful. I mean, it's sort of hard in the webinar format, but if it wasn't, then I'm happy to say more.
Yeah, that was super helpful. It's interesting. I'm going to be greedy and take up a tiny bit more space and push a little bit further on this last point. Because I definitely agree that this overarching goal is going to bring about or highlight different scientific goals. My immediate reaction to what you're saying was that it feels to me like in alignment, explaining what's going on and understanding what's going on is especially important, which is kind of different to what you suggested there. So like on a meta level, I really like that, like trying to ask this question of, okay, which scientific aims should we put forward given our overarching aim? I think that's a very useful one. But I'm wondering if you have more thoughts on like when explanation might be relevant or why understanding might be relevant. Like,
Mhm.
I guess one kind of thing that you might want to do, which is, I think, something that most people in the alignment community are not trying to do, would be to try and build an agent of a particular kind. And I can imagine that requiring a particular kind of explanation, maybe, or a particular kind of scientific aim. But I do think that there's maybe a particular stress or maybe a unique kind of emphasis which is being placed on not just trying to predict the likelihood of failure or something like this, but trying to prevent the worst case scenarios from ever happening. Where if you're trying to build a system which you can put like some very strong guarantees on never going rogue or never going particularly astray, that might emphasize actually understanding what's going on a deep level, because you're never going to be able to come up with a statistical model, or never going to be able to predict in some kind of loose sense, but you're going to want to have an explanation because you're going to want to have a guarantee or something like that. Yeah, I'm wondering if that.
Yeah. No, this is great. So let me follow that with a couple more considerations. So one is that I would want to break open the space of scientific goals even further and say that in addition to what is sometimes talked about as prediction and explanation, we also are going to be interested, and this is, I think, directly relevant to your point about control, right? The ability for us to have this manipulative capacity, but also a goal that is not highlighted as much, I think, but is quite valuable, is characterization. So a lot of scientific activity is simply what you might think of as figuring out what's there and somehow like detailing those features. And part of the reason why we don't typically think about that is because we sort of, it's a background activity. Sometimes it's been done by earlier generations of researchers, but it does seem like in the space of artificially intelligent systems, or those things claim to be such, there's a lot of characterizational work that's still in front of us. That is ways in which we just come to have a better understanding of what the systems are and how they work. And that's not identical to the explanatory understanding, which is a further step, but we don't want to neglect the sort of characterizing exactly what it is we're working with. And one of the ways to do that is through, as you highlighted, building. I mean, there's a tradition that emerges in the early modern period that's sometimes called maker's knowledge, where the idea is that you come to have a distinct kind of knowledge about the system to the degree to which you can build, make, create in that sort of way. And in fact, interestingly, is very much associated with the tradition of craft, where, you know, a good brewer, right, has a kind of maker's knowledge. But that maker's knowledge is actually sort of independent of certain kinds of explanatory knowledge that we might associate with brewing. Like the brewer doesn't have to know about microorganisms and sort of how they work. And, you know, they have to have a sense of how long to set aside their ingredients and under what circumstances, but they don't actually have to have the same kind of knowledge. And so then there's this interesting question about the intersection of the different sorts of knowledge that we might have, and that in some sense, the space of artificial systems raises this kind of craft making knowledge back to the surface in important ways, and especially for control, especially for the ability to make sure that nothing happens. And that actually brings me to just one more point, which is that I think that for thinking about systems where you could have failure, the engineering sciences have thought about this a lot. You know, they have safety analyses, right, where the whole point is to sort of probe the system in certain ways not because you can figure out all the ways that it could fail. That's often impossible, but you can have a sense of the ways in which you need to bound the system in order for certain ways for it to fail to not happen. And one might argue that what is needed in the space for some of the systems that you're studying is something more like a engineering safety analysis. That needs to be very actively applied. And it's its own literature. There are principles for how to do it that are derived from situations in human society where major failures have happened, and to try and then get to the bottom of that in order for failures to not happen in the future. But could you apply some of those principles into the context of analyzing artificial systems? It seems like there would probably be great profit in doing that.
Yeah, for sure. Yeah. Thank you so much. I've recently been talking to a few people who are working on like risks in complex systems from this like very practical engineering approach. And yeah, from what I can tell, there is a lot to learn. Got more questions here?
Yeah, I have a question. Thanks for the talk. I'm just wondering if you could speak a little bit about how you and your colleagues, other philosophers, think about agency in relation to optimization. There are lots of different types of optimization paradigms, and in a sense, it almost seems in conflict because you give a cost function or a reward function or a free energy functional, etc., and you do the computation. It seems as if actions are sort of determined, given that you carry out the computation. So I'm wondering if you could speak to the nature of optimization a little bit and how you think about it.
Yeah. So great question. In a number of areas of biology, you have optimality modeling, which is exactly the kind of space that you're highlighting. You adopt some kind of value and you ask whether or not within the model, optimality model, where that feature is the key variable, it is optimized in some expected way under some time scale. And a number of studies show that there are good patterns that seem to suggest that the systems are operating close to optimality for that said feature. However, what has also been shown is that the system is oftentimes subject to very different kinds of constraints in the sense of features that it or variables that it would ideally want to optimize that set up certain kinds of trade-off relations. And that when those are taken into account, they lead to a more sort of messy, but maybe more realistic kind of modeling of the system. The system is able to accomplish the goal, but not so much in a way that is exactly what the single model of optimality would suggest. So just take a garden variety example of homeothermy in temperature maintenance for an organism. For a long time, the modeling was, does the system maintain this temperature over a longer time scale? And so measurements were made over longer time scales, and then it was shown that yes, this system does seem to optimize this particular temperature Yet when at a later point, measurements were made on a finer grained timescale, it was clear that the system had a lot more noisiness in it, a lot more fluctuations, and that what was being captured at one timescale in terms of optimality was hiding a lot of interesting behavior that the system was undergoing on shorter timescales. And so I think that, these are the sorts of considerations where when one is doing optimality modeling, if you have adopted this orientation of I'm making modeling choices about how to study the system, you're more sensitized to the fact that, oh, well, I made a selection of what variable, how I was going to measure it, under what time scale, and all of these sorts of things become much more, they're not just, oh, the obvious way to do it. No, they were intentional choices on the part of the researcher to study the system that way. And then you could ask, and I think you're more likely to ask, could I study it differently? Could I adopt different measurements, different timescales, different cost functions, and the like, and that we are more likely to generate robust, deeper understandings of systems when we have modeled them under more of those scenarios rather than fewer. And sometimes the temptation in optimality modeling is that if I've modeled it and my model shows relatively good empirical fit, then there's a temptation to think that we understand the system because of that fit, rather than to treat it in a more exploratory fashion and say, okay, what happens if I tinker with the parameters and think about this in a slightly different way. So in that respect, I guess the slogan is that optimality modeling is a tool, and one must use tools with care. And that if we get locked into a certain way of using the tool and think that our sort of understanding is derived from that only that one way, then I think we're in danger of trapping ourselves in certain ways. And again, I think this is why shifting away from the single way of looking at things to the modeling choices has at least the potential to prime us to think differently and to model kind of more heterogeneously than maybe we would be inclined to, because all of us, and this is not, it's not a commentary on any particular discipline or anything like that, it's just a commentary on being human. We have a tendency to use the tools in the way in which we've used them in the past because they have helped us do the things we want to do. And so and that applies in a scientific context with spades. And we just need to be very careful that we have not trapped ourselves inside of particular methodological boxes by virtue of the path dependency on how we came to do inquiry and think that it's the right way to do it for whatever systems we're studying.
Great, thank you.
Do you want to ask me, Josh? Yeah. Hi, Alan. Thanks a lot for the talk. That was great. So I'm very sympathetic to what you were pitching here. So I think that a reason why, particularly in AI safety stuff, there is a lot of falling into this sort of unproductive trap of focusing on what agency itself is because unlike in biology, where primarily, I suppose, we're studying systems that actually exist, in AI safety research, we're also very concerned with ones that don't exist, that we can't currently study. So we're kind of looking for the landscape of possibility of where could these risks pop up given just all of agency. And so I guess that leads a lot of people to be like, well, I want to understand in the most general terms what this thing is so I can understand that landscape. And so I'm sympathetic that actually a better approach is, as you say, to focus on the kind of the packages of these agential properties. And do you think that a possible
better way of approaching these things is to kind of try to identify interesting or particularly dangerous, if coming from the safety goal, right? Like constellations of these agential properties? Or do you think that that will fall into the same kind of trap of basically now just asking, what is a dangerous agent in this particular sense, and then debating about that? Or is it, does it seem viable to you to do that kind of thing or not?
So, again, really interesting question. Let me come at it from the biological side and then circle towards the original setting that is of interest to you. So one of the things that has exercised biologists for a long time is, what's the possibility space for organisms? And one of the things that has happened repeatedly is that fossils have been discovered, or organisms have been discovered in unexpected places, like thermophiles in extremely hot thermal vents, that kind of made people go, oh wow, this is not what we thought. I mean, even at the more garden variety level of, for a time people didn't think that bacteria could live inside of our stomachs because the pH was too low. So there is a sense in which that kind of realization that the possibility space is broader is part of the dynamics of investigation. Like, could you have figured that out in advance? I'm not sure. I think that some of these things might be simply natural consequences of continued investigation. And so that sets at least a little bit of a, call it a kind of calibrated warning that, we might not be able to achieve that fully general perspective from first principles. Right, that would sort of be maybe a little bit more of a physical science orientation, is saying, well, if we had the first principles, then we might have that sort of general perspective that we need, and then we could anticipate all the possibilities where things could go awry. So then I think let's translate that into the context of AI safety. And say, okay, one of the things that we're distinctly worried about are systems that don't yet exist, systems not yet built. How might we sort of do the equivalent of, finding fossils or, unexpected organisms somewhere to widen that possibility space so that we could think more generally about the safety question. And I think the answer to that is going to be probably in this space of maker's knowledge that we were talking about before, where to some degree we're going to learn that by trying to make it and by trying to do it. And that's got the same occupational hazard as gain of function research on viruses, right? That is our capacity to understand how viruses accomplish their infective behavior is something that we can learn by giving them that infective behavior, but at the same time with the possible consequence of it being something that could escape the laboratory context and potentially be harmful to humans. And so if we are engaged in that, we are engaged in a sense, dangerous game. That is, there's not going to be a circumstance where one can do research on viruses or even in some areas of physics, I think, like with nuclear power or something like that, where there's absolutely no danger, or we could somehow avoid it all if we thought carefully enough about it in advance. I mean, again, we probably are bringing ourselves back into the space about engineering and safety analysis. to sort of address some of those things. But I do think that you would be able to move past a kind of squabbling about whether or not something is dangerous because under certain circumstances, because you would be able to sort of catalog these circumstances where, you know, under these ways of looking at the system, and the system has these properties, it can be dangerous in this way, is an achievement. It's something that you have, and now, even though, yes, it's not the same thing as saying we know for all circumstances what will be dangerous. We do know under some circumstances what will be dangerous, and that is an achievement in and of itself. And I guess the question will be, with respect to community expectations, are we sort of doing sufficient sort of excavation of the possibility space so that we don't get, you know, blindsided in certain ways? And my hunch is that there are better or worse ways of doing that, but probably no scenario under which one can be somehow completely safe. Maybe that's pretty pessimistic, but
Sobering, but very helpful. Thanks.
To people from the, well, Nora had her hand up. Maybe we'll let Nora ask a question, then come back to the room if you guys have another question.
Cool. Can you hear me? Yeah, perfect. Yeah, so my question is, so you talked a bunch about sort of the benefits of sort of pluralism in like the perspectives and the modeling choices we make, and maybe even just like the way we operationalize what we mean by agency or what we're interested in. And that all makes a lot of sense to me, both intuitively, pragmatically. I am curious though whether, like, there's some examples in the history of science. I'm like vaguely aware of, like, for example, the case of temperature, where there was definitely a phase where we sort of like very unsure whether temperature is like an actual thing or just sort of like a cluster of like related phenomena. And then eventually we sort of came to have a really sort of solid thermodynamic understanding of like, this is temperature and that's just exactly what we mean by this. Yeah, I don't know, like, is there a chance that like agency is also similar in type to temperature, and then we could in some sense find like full thermodynamic or some other level of description explanation of that? And like, how will we tell whether that's what agency is like? How would you go about that?
Yeah, so this is a great question, and it's also really good to think about this historically and thinking about how we came to conceptualize certain kinds of physical dimensions. I think that there's two ways I would respond to that. One is, I would say that even in the case of temperature, and I would say in terms of other physical dimensions, it turns out that things are sort of, they may be precise in certain ways, but they're not necessarily as unified and monistic as we might think. So a good example of this is actually hardness for materials in material science. So we might think, oh, well, that's like a basic physical principle, how hard something is. And it turns out that if you look into materials science, they have a number of different tests for how hard one material is compared to another. And it turns out that those tests are subject to contextual specification, and even in some cases yield conflicting results, so that X is harder than Y in test 1 and Y is harder than X in test 8, something like that. Now, that doesn't confuse the material scientists, because the material scientists are very clear about their context when they're using the notion of hardness and what it means in that particular context. So I think that I would have an expectation for the concept of agency in the long run to admit of more precise delineations like that. But of course, that's also consistent with not yielding a single delineation of the concept that is somehow going to be a consensus definition. And I think that's a more plausible long-range expectation for a concept like agency, and for other concepts that are commonly used in the sciences that are not fundamental constants or those sorts of dimensions, and that that's okay. I mean, so basically what that sort of suggests is there's progress to be made, right? It's not like we're stuck with this like inherently unclear concept that could mean different things, right? So go back to the discussion about species, right? Do we understand species better now than we did 200 years ago? Absolutely, right? Was that because we came to a single agreed upon definition of what counts as a species? No, right? And so that's the kind of dynamic that I would have an expectation for in terms of agency. As I would say, I envision us coming to a better understanding of agential properties and how they work, what they're like, under what condition they operate. But that's not the same thing as saying that we will get to the single consensus definition of agency. That would somehow mean it's more akin to a physical dimension like temperature. Does that help?
Yeah, that's helpful. Can I maybe just a very quick follow-up question, sort of at the other end of the spectrum, right? Like, there were also concepts we have used in the past that we actually just generally came to realize they were like completely misguided. Whatever, phlogiston or whatever. Again, like how could we tell if that's the case for agency?
Yeah. So I think there, the test for a concept is its capacity to facilitate productive work in inquiry. So if a concept is losing that capacity, then we have reason to think that it should be eliminated. And that in a case like phlogiston, if we were in 18th century chemical inquiry, it would have been much less clear that we should get rid of phlogiston. Because at the time it actually was making a difference in how people were thinking about stuff and designing experiments and the like. Later, not so much, and it's ditched. I think that one of the possibilities for agency, and it's a live possibility, I don't sort of have deep intuitions about whether it's the case, is that we might want to say, look, let's break up agency into these separate features and stop talking about something globally like agency, right? Let's just talk about, feedback organization that facilitates action. Let's talk about, affordances in an environment that foster genuine alternatives or something like that. And I think that the willingness to do that is going to be a function of to what degree is it the case that severing some tie to the general notion of agency is the productive move. And the reason why we have to be careful there is because we know that other concepts have not severed that tie. Again, species, gene, homology, other examples where this has happened, have not severed that tie, but have shown this pattern of productivity. And so we certainly don't think that, you know, hardness or gene or homology or species is like phlogiston. But we also could say that they're maybe different from temperature. And so we would just want to then be sensitive to those possible trajectories for what could happen to the concept. But it seems like, if anything, agential questions are sort of returning to increased sort of productivity. People are paying more attention to them even than they might have been at some points in the past. And so we have probably less reason at the current moment to think that agency would go the way of phlogiston, just for one comparison.
Cool, thank you so much.
Yeah, so I think people in the room had another question.
Hi. Yeah, I really appreciated this splitting the problem into parts and focusing on the properties. There's one property that a lot of people in AI safety are really focused on, and you touched on it a little bit, I think, in your example of the squirrel hiding nuts.
Mm-hmm.
But it's this sense of time and being able to coordinate with yourself over longer time horizons, and as opposed to systems that are like really deeply myopic. I was just wondering if you could touch on that a bit.
Right. Okay. So good. So there's two things that I think are important about your question. One is, we might say we need to pay attention to the gap of time between input and action, right? That's one key thing to pay attention to. And that, as I mentioned, a number of researchers for biological systems have thought that the gap between input and action was, in some sense, a signal that more agential-like features of the system were being engaged. If there was a collapse in the time, there was an automatic stimulus response, somehow that was not agential, reflex, something like that. Then there is this additional thing, which is self-coordination across time, right? And this, I think, brings us into the space of questions about representation of goals, right? So in the case of the squirrel, right, the squirrel is not only able to engage in a activity that is time dilated in some sense, the caching of a nut to be consumed at a later point, but that also in some sense the squirrel is coordinating that it's going to like know where it is. And it's, you know, I mean, people might be inclined to start thinking, does the squirrel have a mental map of the cache sites that it puts the nuts in? And this has actually been a question for animal locomotion, for like dead reckoning in ants, and trying to understand how is it the case that ants can travel between points where they are in the nest without certain kinds of cues that seem like they would be needed to do that. So I think that's where I would say that the key thing that maybe is a question is whether or not the capacity for having some kind of, call it a bridging link, that takes behavior at earlier time and connects it to behavior at later time under some scheme of coordination. I engage in behavior at earlier time in order to contribute to or support behavior at later time. Is probably really, really crucial also for this idea of making a mistake, right? That the degree to which the coordination is somehow faulty or something like that would make us think, oh, some kind of mistake is taking place. Now, if we move into the space of AI safety, right? And here, I mean, definitely, I'm happy to hear the input because this is definitely not stuff I'm as familiar with. I take it there's probably some precise concern that there is no coordinating, right? And that the lack of coordination in part is related to the fact that we don't think that the system has a overarching representation of the activities at earlier times and later times in that same sort of way. And so maybe that then is, part of the question about AI safety is that do these systems need to have explicit representations of their coordination across time? Because if they don't, then we can't actually detect when they are potentially going to go wrong.
Actually, I think so. I mean, to some extent, I think that people are worried about they would like if there are long-term goals, for those long-term goals to be explicit. But actually, I think the focus is much more wanting to avoid systems that do any kind of long-term coordination at all. That like myopic systems that behave like that are maybe more like, can be seen as more like tools and less like agents. And people generally feel a lot better about like their safety properties than systems that are like do long open-ended kind of stuff to the world.
Yeah. Okay, so actually, I'm translating this in real time, but I'm actually hearing you articulate a kind of safety engineering principle, which is that the degree to which we want AI to not have dangerous agential-like capacities, then one of the things that we should do is design these systems so that they do not have capacities for long-term coordination.
Yeah.
Well, I mean, yeah, from at least from a safety perspective. Yeah.
I think one worry in the safety community is that, I mean, there was a lot of research done on like what would it be to have a myopic AI, or an AI that only cares about T+1. And a lot of the, I think, increased worry has come from that seeming from the outside, like maybe a relatively simple or at least straightforward problem to solve. And the more that you look at it, the more it seems impossible to actually pin down a system in this way. And it's like more and more likely that actually, no matter how you cut it up, there's going to be some way that coordination across time emerges, even if you try and suppress it. And I think that's where a lot of the worry comes from.
And of course also that like building systems that do that are like this are likely to be economically like useful. And so companies that are developing this kind of technology are looking for ways to develop stuff so that human oversight only needs to be applied occasionally, and that it can do lots of long runs of thinking on its own. Just there's just an economic incentive for that.
Yeah, right. And I think that highlights again something that you would expect from the engineering context, where you would be trying to build something that is safe, but you wouldn't build it so safe that it bankrupted your company. You're building it safe under the strictures of, we have economic constraints, or we want certain kinds of economic goals achieved as well. This point about the systems, potentially not being able to avoid having the potential, at least, for long-term coordination is interesting, and it actually was making me think that there's a potentially interesting comparison to be made with one of the relatively still unexplained but interesting features of biological systems, which is why they sleep. So why do organisms sleep? Sleep is observed across a whole diverse set of systems, and the way in which sleep occurs is very diverse, the amounts of time, all alike. But what seems to be a relatively consistent feature of most organisms is that there are ways to shut down. There are ways to go offline. And some of those can be quite severe, right? So you can think about a, like a soil worm that is encountering frost conditions in the late fall, going into a diapause that will bring its metabolic rate down through the months of winter, and it will only reactivate when temperatures come up above a certain level. So you can think about sleep on this kind of scale of different ways in which an organism can sort of really dial down its activities. Hibernation would be, maybe a more familiar example. So then, maybe what is interesting from an AI safety standpoint is what is the analogy for sleep, or something like that in an AI system? Like what, and could that be the sort of thing that prevents certain kinds of runaways? Because if we think about, well, what happens when a biological system doesn't sleep? We know all kinds of things go haywire, right? All kinds of systems don't work the way they're supposed to work, metabolically, perceptually, and the like. And so is it the case that we could somehow build in a sleep analog for these AI systems? I mean, I don't know. I'm totally like thinking out loud with you on the fly here, but
this is interesting. One question I think is maybe a much longer discussion, but I do want to bring up is, I know one thing that I'm very interested in is thinking about analogies between AI and other evolutionary systems. And I know this is stuff that you've also written a bunch about. So like thinking about the analogy between AI and maybe an ecosystem, or maybe an AI and a learning algorithm and evolution as a whole, and maybe thinking like, is there an analog to evolvability or an analog to contingency or these kind of things?
Yeah.
I think I'm bringing this up just to decondition a little bit from this like agency as organismal agency.
Yeah.
There's also a lot of biological stuff around like agency, the as if agency of evolution, or like how do we account for apparent evolvability when evolution is maybe a myopic process, and then like can we see evolvability as like a long-term coordination between different evolutionary processes, and then also like ecosystem stuff, which kind of breaks down these individual barriers far more, and learning and adaptation in ecosystems might be seen completely in different terms to organismal agency, but still be irrelevant to what we're looking at in AI systems.
No, this is really good, because it's nicely bringing us back to this point about, one of the things that we need to pay attention to in thinking about agency is this population, social structure, other sorts of things, which would then de-emphasize the organism as the locus of agency. And so I mean, I think this is where the exploratory nature of my proposal really could get some traction. So let's just take the ecosystem comparison for the moment. So if you go over and you look into ecological modeling, right, we know that systems have been modeled in terms of equilibrium dynamics, and sometimes in terms of non-equilibrium dynamics. And trying to understand, does the system have natural equilibria, or is that actually the wrong way to think about the system? And these are debates that occur among ecologists and how they model those ecosystems. Well, maybe that's exactly the sort of exploratory work that needs to be done, in thinking about these artificial systems, is that, are we thinking about the ecosystems in one way? And if we shifted to thinking about them in another way, we would get a different insight onto what could be going on. We are not going to be doing that if we're not thinking about it as a modeling choice. If we're not thinking about it in this, I make a choice about which properties to focus on and how to investigate the system, because we're then going to be most likely just trapped in whatever ways are the most natural, comfortable, easiest that we reached for off the shelf. So I totally agree with you there. I mean, obviously, you could think that the analogy with, say, natural selection and random mutation and variation and natural selection, you would get a kind of a capacity for a system to explore the space and come up with solutions, and then you could sort of say that, well, we've got this new research that shows that some bacterial systems actually have mutator alleles, which allows them to increase the mutation rate under stress, which allows them to speed up that search process in a way that would allow them to find a solution. At the same time, we also know that taxa go extinct. And so it's not the case that the system can always find a solution and respond in adequate timescales.
Yeah, for sure. Yeah, I'm going to stop myself because there's hours of thoughts down.
It's really interesting stuff. Yeah.
Yeah, I would like to pause, and we're over the originally allotted time. I want to give you a chance to like put a limit on your time.
Yeah, I could go for basically I need to do a hard stop at 1 o'clock. So if I can go for like about 10 more minutes if people have a few more questions.
Yeah, sure, that sounds good. I noticed Sahil had his hand up and put it down. You haven't got a chance to ask a question, so you're welcome to do that if you like. Otherwise, I'll give you a second. Otherwise, we'll just let Nora ask a question.
Oh, can you hear me?
Yeah.
All right. So one question that AI safety researchers don't think about, or they will insist that they will never have such sinful thoughts, is anything to do with the philosophy of mind. And normally I would be more polite and wouldn't bring it up. But I did love how neutrally you laid out this sort of goal relative feature, the 4 features that you laid out. And I guess you've sort of, depending on one's view on the philosophy of mind, maybe representation is one you touched upon, which is somewhat close. But there's something about something non-relativistic about the suffering of a sentient being. Like if you're tackling those questions, it seems like whether you suffer or not is not dependent on how I model you. And the crisp version of my question would be, do you think people who are interested in the philosophy of mind should also abandon a single conception of agency, or is that slightly different? And
Yeah. So this is right, its own can of worms, because the philosophy of mind has lots of investment in some of these debates. So I think the perspective you're getting from me is a perspective that emerges from a lot of philosophical work on the sciences, where people have recognized that concepts play different roles than they might have originally been thought to, and that they can behave well, even though they don't behave like maybe some philosophers thought they should. However, in some of these literatures, philosophy of mind being one, the debate is framed in terms of what is the right definition of agency, at least within philosophy of action. And so to adopt the move that I recommend sort of sounds like you've changed the terms. You've left the building, but we're not doing the same thing we were doing. And I think that's actually a kind of fracture line in how we think about the role and value of philosophical inquiry. And I'm definitely not going to be able to adjudicate that, today. But what I can say is that I've written about this. In fact, on a couple occasions, but most recently in an essay review in Analysis, where I try and highlight that one of the real advantages of philosophical thinking along the lines I've been advocating is that it is distinctly suited to ongoing problem-solving endeavors that humans have. And that's actually been a major criticism of the way, especially institutionalized philosophy manifested in the 20th century, which was seemingly kind of retreating from more practical questions or applicable settings for the philosophy, and more internal debate among those who were already kind of in a very small elite conversation to start with. So, at the end of the day, I would advocate that there's some reason to think that this sort of orientation would have those recommendations for the debate among the philosophers themselves. However, I think that the good news is that for those working on AI safety or other sorts of things, I think that those debates don't have to be settled for you to adopt that orientation and to benefit from it. And I think that it's a good reminder that sometimes those debates do have a kind of sort of stalemate structure to them, where they feel like people are moving in circles. And there, I think the way to look at it is to shift into a different space and to say, okay, but the biologists didn't get stuck on the fact that they couldn't come up with a single definition of species, right? They debated it, they argued about it, people had strong views, but they didn't get stuck. And it seems like in some of these philosophical conversations, people have gotten stuck. And that at least one way to get unstuck would be to adopt this methodological shift in how we ask the question.
Thanks. Do you want to give me a title or drop a link to the paper?
Oh, yeah, actually, I can do that really quickly here. Let's see. Give me 1 second. Because I think I can just put it in the chat and it should be available to everybody, right?
Yeah, just make sure you switch it from, I think it starts off on default as only to host and panelists. So make sure you switch it to everyone.
Okay.
Nice.
All right. So people can tell me if this comes through.
Yep, that looks like it went to everyone.
Everybody get that okay? Okay. Yeah, so that's just one place where I've kind of made that style of argument, but I'm certainly by no means the only person to do that. So if people want to follow up, I'm happy to point in a few more directions to others.
So I'll give you and Nora the last word.
Okay.
If you want to go for it, Nora.
Yeah, sure. Would you already hear me? Okay, cool. Yeah, so I have one more question. It's a bit following on some of the things Clem alluded to in the last question. And you also mentioned this earlier. So there's also forms of agency that we might describe as nested or like hierarchical or sort of like, collective. And yeah, I'm sort of interested in this broadly, whether you have what you have interesting things to say about it. Maybe one specific question I'm interested in is I'm interested in sort of the relationship between sort of air quotes the agent within this hierarchical structure. So if we have agents at the lower level, which we might be able to describe as agents to some degree, but we also might sometimes want to describe the super agent as an agent. What's the relationship between those two entities? If one gets more agentic, does the other one get less agentic? If the one gets more, the other one also gets more agentic? Or are there notions of maybe alignment and misalignment that arise between these layers? Or just sort of what would it even look like to have a theory or an understanding of how these layers of agency or levels of abstraction relate to each other?
Yeah. So two quick responses to that. One is that we have good reason to think that all the combinations are possible, in that systems that we don't want to think of as agential can in aggregate exhibit agential-like properties. Systems that are agential can also sort of aggregate into more agential-like systems, and that systems that are agential on their own can aggregate into systems that themselves are not agential or exhibiting agential properties, even though they're aggregate. So I think we can find all those combinations, and that's interesting that we can find those combinations, but there are patterns in the combination of exactly the kind that you describe. That is, in cases where we have reason to think that the individual components have some degree of agency when they are participating in a larger structure that also seems to have some kind of collective agency, there does seem to be what we would call a giving up of some of that individual agency. And probably the best garden variety example of that is cancer, and thinking about cells in the context of a multicellular organism and the way that they are aligned or not aligned with the organism as a whole, and the existence of cancer and the capacity of these cells to adopt fates that are in some way independent of the collective agent, sort of shows this in a relatively poignant way. There is some interesting work on this that argues that that's actually something that emerged evolutionarily over time, where some of that individual agency was ceded in some sense to the whole. I'm happy to send you a paper on that, but the point is just that all those combinations that you identified are there, and I think can be studied and learned from in interesting ways.
Cool, yeah, that's great. I'd love the reference. Also, maybe just very quickly, are you aware of any work discussing or maybe attempting to operationalize what we mean by the cancer cell is becomes unaligned with the overall system, just to measure that or just make that more concrete or operationalized?
Yeah, let me think about that and get back to you with references. I think there's more than one place that's being done, but I want to double check and make sure, but I can definitely follow up with you because there are people who are working on that.
Cool, awesome. I really appreciate it. Thank you.
Thank you so much.
Yeah. Well, thanks for everybody participating. Thanks for the time and great questions. And I really enjoyed it. And if people do have some particular follow-ups they'd like to engage me with, I'm happy to respond as time and schedules allow.
Yeah, thanks, Alan. We really appreciate it. That was great.
Thank you.
All right. Yeah.
Bye.
All right. Take care. Bye.
Take care.